All right, today we're going to be talking about determinants, not so much Cramer's rule. So let's get this out of here a little bit. All right, so we're going to go ahead and evaluate determinants today. In order to evaluate determinants, they must be a square matrix. It gives us one single answer, like a 4 or a 5. It's not a matrix answer, it's just an actual answer. And we always do down minus up. I'll show you what that means in just a minute, but down minus up. All right, so this is a second order determinant because it's a 2 by 2. Again, being a square matrix, it means that, I guess I didn't explain that very well. To be a square matrix, it has to be a 2 by 2 or a 3 by 3 or a 4 by 4, so on and so forth. A 2 by 3, you can't do a determinant with. So anyways, so we have a second order determinant, which is a 2 by 2. Now, we can write it one of two ways. We can either go DET with the brackets, or we can have like the absolute value symbols. And what we do is we do the diagonals. So notice the diagonal here, it's AD. So that's the first one. That's the down diagonal, it's going downhill. And then the up diagonal is here, CB. So it's the down diagonal minus the up. That was down minus up. So we go down AD minus CB. So here down is 24, up is negative 15, so 24 minus the negative 15 is 39. So let's go ahead and try one here. All right, so zeros are really nice in determinants because they're going to make the multiplication real easy. So we're going to multiply the diagonals and then do down minus up. So 6 times 0, which is, of course is going to give us 0. Then negative 1 times 4 is going to be negative 4, so 0 minus a negative 4, or 0 plus 4, which gives us 4 as an answer. Real easy. Doing this again, down is 3 and 0, which is 0. Up is 1 and 2 is 2, so 0 minus 2. Down minus up is negative 2. So a 2 by 2 is really easy to go ahead and do. What about a 3 by 3? 3 by 3s are a little bit bigger. It's not just the same down minus up. What we're going to have to do is we're going to have to rewrite the first two columns on the right side. Then we're going to do diagonals. There will actually be 3 diagonals down and 3 going up. You'll add up all those diagonals, and then we're still going to do down minus up. The second sum is down, and the first one is up. So let's see this with an actual example. So here's our 3s, 3 by 3. So we can go ahead and do this. So we're going to take this first 2 columns here, and we're going to rewrite them. So rewrite the first 2 columns to the right of the determinant. So 3, 2, 1, 3, 2, 1. Negative 2, negative. We're writing it there so it's a little bit easier for us to see the diagonals because they do wrap around. All right, so now we're going to do the up. So we're going to do there's 3 of them here, starting at 1 going this way, and then 2 and going up, and negative 3 going up. So let's go ahead and show you that. So, they're going to do the down first. So here's the down ones, 3, negative 1, negative 3, which is 9. The 0, of course, again, is really nice. Like I said, that's 0. And 1, 2, and 2 is negative 4. Now we do need to total this up. And now we're going to do the up ones here. 1, negative 1 is 1. The 0 again gives us 0. And there, that gives us 12. So we will need to total both of these. This is 13 here and 5, of course. So 13 and 5. And then we're going to do down minus up. So the down was 5, the up is 13, so 5 minus 13, or negative 8. So the value of the determinant is negative 8. So what about this one? 2, 0, and 5, that's easy, that's 0. Negative 3, negative 2, and it would be 1 for 6. And then negative 1, 5, and 2 for negative 10, totaling that up for negative 4. We're going to do the ups. Again, 0 to start with. 2, negative 2, and 2 for negative 8. 5, 5, and negative 3 for negative 75. So negative 4 and negative 83. And down minus up for 79. All right, that's how we do these determinants. So why would we use determinants? One of the major things that we can do with determinants is if we have a triangle, we can actually find the area of a triangle. Now remember, area of a triangle is 1/2 base times height. There's that 1/2 in there. There's also a 1/2 in this formula. So it's 1/2 the determinant of that triangle. Now remember, the triangle has to be a 3x3. So the matrix has to be a 3x3 in order to do a determinant. So when I go ahead and I start putting these values in, x, y, x, y, x, y, I'm missing that last column. We can't put zeros in there because that's just going to make everything 0. But we can put 1s in there, and that will make it a 3x3. We can do the determinant, and then we'll get 1/2. It is possible, by the way that the determinant is run, that we could get a negative value. If it's negative, just go ahead and make it positive, where we're talking about the absolute value of that. All right, so area is obviously going to be positive at all times. So if we do end up, depending upon how you plug in your coordinates, you can get a negative number. Just make it positive. All right, so a surveying crew has 3 points on a map: 0, -1, -2, -6, and 3, 2. 3, -2, sorry. So can we use that to find the area of a triangle? Absolutely. So we're going to do the first order pair, second, third, 1/2 on the outside, 1's down the side. So plugging those in order to do this, of course, we're going to rewrite. We're going to do all of our down angles. This one, of course, is 0. This one's -3, and this is 4. Up angles, 3, -6, and 1 is -18. 0 on that one, and 2 on this one. So 0, -3, and 4, giving us 1. -18, 0, 2, giving us -16. And again, it's down minus up. So 1 minus the -16, which is 17. 1/2 of 17 is 8.5. So we have 8.5 units here. And remember, they did a conversion here that each square unit is 100 square miles because it was on a scale. So talking about 850 square miles for this triangle. How about another one? 2, 3, first row, -1, 2, and 0, 0. That's a nice one. Replacing the 0, 0, we're going to get a lot to cancel out. So here's our down: 2, 2, and 1 for 4, 0, and 0, giving us 0 out. Going up, 0 that way, 0 that way, and so we're only dealing with this last one, which is -6. So it's 4 minus a -6, which is 10, and we do 1/2 of 10, so our answer is 5 units squared. All right, that's what I have for you today.